Assalamualaikum everyone. So today, for our group will be presenting about our project which is melanoma skin disease image classification using recurrent neural network versus recurrent neural network plus support vector machine. So our member is me, Ahmad bin Hakim, Muhammad Ikhwan bin Rosmaini, AZZARUDDin bin Abdullah, and HEDZWEEN bin Muhammad PUAD. So let's go to the introduction first. So for introduction, melanoma is a deadly skin cancer, which is the most aggressive type of skin cancer. It is capable of rapid metastasis, which is mean it can spread through the skin, to the organ very quickly. And early detection is essential to increase survival rates and reduce treatment costs. So some of the challenges in traditional diagnosis is it requires invasive biopsy procedure. It is time-consuming and dependent on dermatologist expertise. It also has high chances of misdiagnosis in early stages. So we can understand some of the melanoma stages. So for stage 1, the cancer cell has appeared but it has not spread beyond the skin. So, and then the second stage is still a steady stage. Is the tumor is getting thicker but it has not spread beyond the skin. Stage 3, regional spread, which is the cancer has spread to nearby lymph node or skin. And stage 4, metastasis, cancer has spread to distant organs such as lung and liver or brain, and this can be very fatal and lethal to the patient. And the role of artificial intelligence and deep learning. It can automate and speed up the detection process. It uses image processing and feature extraction for accurate analysis. I can classify melanoma stages non-invasively. So for our project overview, for RNN versus RNN plus SVM in melanoma classification. Image segmentation enhances lesion isolation using binarization and canny edge detection. Feature extraction, analyzing asymmetry, border roughness, color, texture, and entropy. Deep learning model. RNN, recurrent neural network, processes sequential data for melanoma classification. And RNN plus SVM combine deep learning with support by vector machines for enhanced accuracy. Objective is to develop an AI-powered classification system to assist dermatologists in diagnosis and staging melanoma swiftly, reducing misdiagnosis and improving treatment planning. So for the next, which is the objectives.
There are 3 objectives, which is the first one, to extract the features of normal and abnormal melanoma skin tissues. The second one is to predict the classification of normal and abnormal melanoma skin tissues. And lastly, to evaluate the prediction of classification and detection of the RNN plus SVM model. The dataset used in the study comes from ISIC 2019 Challenge dataset, a well-known collection of dermoscopic images used for skin lesion classification. This dataset is crucial for training deep learning models to differentiate between benign and malignant skin condition. From the original 8,240 images, we selected 1,329 images for experimentation. To ensure high-quality training, we applied several pre-processing steps, including resizing all images to 218 x 218 pixels for uniformity, normalizing pixel value to a 0-1 range to standardize image intensity, data augmentation, techniques such as rotation, flipping, and contrast adjustments to improve the model's ability to generalize. For training and evaluation, we split the dataset into 80% training data and 20% testing data. This ensures the model learns effectively while maintaining enough unseen data for validation. Additionally, cross-validation is used to further assess the model's reliability by training and testing on different subsets of data. This approach helps in achieving better accuracy and generalization in melanoma classification.
Assalamualaikum warahmatullahi wabarakatuh. My name is Harith and I'm from Group 1. So I will explain about our coding. First, I want to declare that the data set we got is from IC 2009. Problem with the coding is we doesn't have a label for the image, which is the image stage 2, 3 or 4. The metadata only have several detail, like image, like a type of skin disease for each image. So we got melanoma and something. So we decide to make several process to sorting the stage of melanoma by ourselves. But before that, we using the metadata we got from IC 2019 test ground, we differentiate the melanoma skin type disease image with other skin image, and when I run the coding, it will save the image of the melanoma only. So because from the IC 2000 test input, it got about 8,000 plus image, with including several type of disease other than melanoma. So in order to get melanoma only, so we need to use metadata and separate it. So in this coding, it will get the metadata from the MEL, which stand for melanoma, whichever image that got us value 1 at MEL, so it will consider as a melanoma skin type disease. So after the coding is running and got the image, we got about 1,000 something. So if running, it will take about several time. So I will pause. Okay, from 1,337 image, I'm sorry, from 8,000 something, 8,000 plus image, we got 1,327 the melanoma skin type disease. So it is saved as an image data, and this is interesting thing, using segmentation and extraction feature, we will sorting the image by its type. So first thing first, actually this image has we have saved into the melanoma only. So in the melanoma only file, it got only a melanoma without any skin type disease, which is good. And also we also run segmentation like binary mask, like a mask asymmetry, border roughness, color standard deviation, state feature, which we extract feature like value like texture roughness, texture correlation, texture smoothness, and texture homogeneity. So we compute entropy, and based on the extraction and the value we got, we take about 50 to 100 sample and test it, the value of each to get the image, to sorting the image by each stage. And also we using professional clinical staging guide as our guide, which include the size, the roughness of the smoothness of the surface by the value. And after sorting, after sorting the image will label as a stage 4, stage 3 or stage 2, and their extra feature fitness will also be saved, and all the extra feature and the label we will save it as a new metadata called melanoma feature. We save it as CSV file. Okay, when I run this, it will run about 1337 image and save it in a CSV file. So I will pause because it will take some time. Okay, after the extraction feature and the segmentation done, it will be saved as a new metadata called melanoma features. Since RNN process the sequential data, so it's a good idea to process the data using this type of data, because we have got a value in a value data. So using a metadata we got melanoma feature.csv, we use it to train the data. So if we run, we will show the phase training phase for the RNN. Now we wait a minute. Okay, training progress. So it will run about 100 epoch. Learning rate is about 0.01, and the iteration per epoch is about 66 iteration per epoch. So we don't have validation, which is a big disadvantage or big weakness in our experiment. The elapsed time take about 1 minute and plus, so I will pause a little before. Alright, so the training phase is done. The coefficient metric is shown here. The elapsed time about 1 minute and 54 seconds, about 2 minutes, and we can see the test accuracy is about 73.96. So we can test the image, the predict. You can see how to predict. Okay, it predict stage 3. Nice, but it's not just that. We will run, we will train the RNN plus SVM training using the same metadata that we got for extra feature from there, and we just run. The same thing happen. Training process we show here. The epoch is 100 and 66 iteration per epoch. The rate is the same, 0.01, and time elapsed, time taken to training still about below than 2 minutes. Okay, the training progress almost done. So it takes about 1 minute and 55 seconds to run the iteration. So we can see the coefficient matrix for RNN plus SVM prediction. Nice. Okay, how about the accuracy test? The accuracy test is 78.49. It increased from before it's about 73 and 96%. So we can see the increase of yes, increase. So we can test the image. We use GUI. We can test the predicted image. We just use GUI. So oops, so we can see more detail. Okay, test image. It's not there. It's not here. Yes, here. Okay, I copy here. Paste here. Okay, here. When we load the image, we choose one of our image. Okay, I choose it. Okay, we can see we have a edge detection, which I use a KD edge detection, a binary mask. Okay, KD edge detection, I think. Yes, binary mask is also threshold binary mask, and we can see the sample image. So what will predict this stage? When we click the predict stage, it show the stage of the melanoma, and also show the feature value of the image. We can do the same thing for the other. I choose this one. Same stage 3, and we have to choose this one. What's the same? It's still stage 3. How about this one? Stage 3. Yeah, but as you can see, the image the edge detection very mask and the segmented image. Yeah. So we can see this is extraction feature value that will be changed. Follow the image that we test for the prediction. Okay. So that's all from me. Thank you.
Assalamualaikum, my name is AZZARUDDIN. So I will present about the accuracy and the learning rate result. The figure shows the training phase for RNN and accuracy metric for the RNN. The learning rate for this experiment is 0.01. The training or learning process may take about 2 minutes, and the highest accuracy rate after the training phase is 76.89. Okay, next. This is the conclusion. The study compared the effectiveness of the recurrent neural network, that is RNNs, and the RNN plus SVM for melanoma classification using extract image feature. Through rigorous experimentation, results indicate that RNN plus SVM outperforms standalone RNN in classifying melanoma stage, demonstrating improved accuracy and degeneration. This suggests that integrating SVM as a classifier enhances decision boundaries, making the model more reliable for the medical diagnosis. Despite the success of this approach, challenges such as feature extraction limitation, dataset imbalance, and computational complexity remain the key concerns. Additionally, the reliance on extracted metadata instead of raw image may limit the model adaptability to variation in lesson appearance. Moving forward, incorporating deep learning architecture like CNN or hybrid model could further refine melanoma classification accuracy. Expanding the dataset and exploring the real-time image process could also enhance practical application in dermatology. Ultimately, this research contributes to the development of automated melanoma detection system, aiding the diagnosis and improving patient outcome. That's all from us. Thank you.